function g, which we have here in this magenta dotted line, or this red dotted line, can be thought of as a translated or shifted version of f of x is equal to x squared. So f of x is in this bluish color. Write the equation for g of x. So I encourage you to pause the video and see if you can do that. See if you can write the equation of g of x, which is a shifted or translated version of f of x. All right, now let's work through this together. So to think about how it has been shifted, I like to look at a distinctive point. And if we're dealing with parabolas, that distinctive point is going to be our vertex. And how would we have to shift this vertex to get on top of that one? Well, it looks pretty clear. We could shift down by 4 and then 3 to the right. Or we could shift 3 to the right and then down by 4. Either way would be sufficient. So let's first shift 4 down. That's actually a little bit more intuitive. So if we were to shift 4 down, what would the graph look like? Well, it would look like this. Let me see how well I can draw it. So that's what it would look like if we shift down by 4. And one way to think about it, whatever for given x, whatever y value you had for f of x, in this new orange graph, you're now going to be 4 lower than that. So this graph, this is going to be y is equal to f of x minus 4. Whatever f of x value you had, you are now going to subtract 4 from that. So this is going to be y is equal to x squared minus 4. And so the first thing we did is we shift down by 4. Shift down by 4. And so our equation went from just being x squared to x squared minus 4. So our new function, or our new graph, is y is equal to x squared minus 4. Now to get to g of x, we now have to shift to the right by 3. So let me write that down. Shift to right by 3. Let me draw a little arrow here. So we are going to shift to the right by 3. Now this one is a little bit counterintuitive when you first learn it, because when you are shifting a function to the right by a value, you would replace x with x minus the amount that you are shifting to the right. So you would replace this. If we're shifting to the right by 3, we replace it with x minus 3. So this is going to be y is equal to, instead of x squared minus 4, you are going to have x minus 3 squared minus 4. That shifts it to the right. Now it's a little counterintuitive to say, wait, I mean, the vertex value is increasing by 3. Why am I replacing x with x minus 3? Why isn't it x plus 3? I explained the intuition in more depth in earlier videos where we talk about shifting parabolas. But one intuition is that over here, x squared is going to be equal to 0. That's what's happening at your vertex. But over here, if you want to have that same behavior, if you want this same part of our equation to be equal to 0, but x is now equal to 3, well, you're going to have to subtract 3 from it in order to have the same behavior that you had at x equals 0. That might help your intuition or it might hurt it. But the general idea is however much you're shifting in the y direction, if you're shifting up, you add that amount. If you're shifting down, you subtract that amount. When you're shifting in the horizontal direction, you replace your x with x minus the amount that you're shifting to the right. So if you were shifting to the left, let's say you were shifting to the left by 3, this would be x minus negative 3, or this would be x plus 3. But there you have it. That is our equation for g of x. So g of x is equal to x minus 3 squared minus 4. This part tells us that we are shifting down by 4, and this part tells us that we are shifting to the right by 3.